we will have exam next Wednesday. So rather than Monday, I'll make it Wednesday because we need to cover or clarify a few more, some more material. So anyway, it will be next Wednesday, not Monday. Okay? Is the date November 4th? Right? Is that right? All right. So last time I introduced you the concept of interfaces, and the idea was define an interface before we create the class, right? And the benefit is, see, especially in a team environment, if you already created an interface, let's say compute or whatever, right? And you defined a few methods, for example, let's say double compute area or whatever, right? And double radius, for example. Okay, so remember in an interface we simply write the name of the method, what input it takes, what's the return type. No public or private over here. Okay, and same way we can have more. And now once we create, let's say a class, suppose we call it my compute. Now we will say we'll implement the iCompute interface, and then we will write the real code for whatever the methods are defined in the interface. Okay, so the benefit of this is, number one, for example, let's say the class has, 200-300 lines of code. So if it's a few hundred lines of code, see somebody in your project who's coordinating with you may want to call this method, right? Because their goal is whatever useful thing you have written, how can they call this method, okay? So if rather than looking into the code and seeing, what parameters do I pass, what type of result it will give us, okay, interface is hardly few lines of code. So somebody can take a look at the interface and say, oh, this is how I call it, right? And the other benefit is tomorrow, let's say, whatever code you have written, you decide to change it, okay? But if the interface stays fixed, then the calling code does not have to change. Calling code will still go by the name of the method, what parameter, what return type. So typically, before we start writing a full detailed code, we decide on a good interface, and once we have decided on a good interface, we don't change it. And again, interaction between different classes in our projects becomes a lot cleaner this way. Okay? Okay, so as far as interfaces are concerned, there are two types of interfaces. Okay, one are called custom, meaning we define the interface. Okay, and one are called standard interfaces. So standard is basically defined by the .NET library. So the name of the method, what input it takes, what output it gives us is already fixed by the .NET library. Our job as a programmer is to implement the interface and provide the real code, right? So there are a few, for example, popular interfaces that in my opinion every programmer should feel comfortable using them, excuse me, implementing them. So some of the popular interfaces are ICloneable, iComparable, iComparer, okay, iEquality Comparer, okay, and as time permits, we can take a look at some other interfaces as well. But at least first 3 of these, everybody should feel very, very comfortable. How do we program them? How do we use them? Okay. What's the purpose of these interfaces? Purpose of ICloneable is to make in-memory copy of an object. Okay. See, for example, in C#, exactly like Java, okay, suppose you created a class, let's say student S1 equal to new student. And let's say you put some data over here through the constructor, right? Whatever, first name, whatever, right? Suppose this is Bill and so on. Okay, now you try to create a second student, S2 equal to S1, okay? So is S2 a completely separate student? Does S2 have the same data as S1, and does it have its separate memory? Okay, the answer is no. Okay, anytime we assign one reference type to another, it points to the same memory. Okay, to show you, let's take a look at the first line. Student S1. What will it do? It will go to the stack area, create a reference called S1. Right? Now let's go to the new student. So now we will go to the heap area and create memory for whatever first name, whatever are the private fields, right? Last name and ID and test1 and test2, right? And all of these, since we said student S1 equal to new student, will be pointing over here, okay? So now, once we trigger the constructor, it will end up storing Bill and whatever, 1, 2, 3, 4, let's say 85, let's say 91. Okay, so suppose those are the things we were passing in the constructor, right? Now focus on the second line. Student S2 equal to S1. So just what will the left side do? It will create a reference called S2, right? And now we said S2 is pointing same place as S1 is pointing, so all it does, it points to the same memory. So S2, S1 are really the same object. They are not two different objects, right? So for example, after we assign S2 to S1, if you did, let's say message box.show, let's say S1 dot test1 dot toString, what will you see in this example?
85.
You'll see 85, right? Okay. What if I say S2 dot
The same.
same thing, right? So now before I display the message box, what if I do S1 dot test1 equal to 50?
50. It will be 50.
So now, remember, it's the same memory. So if I change S1, right, if I change S1, and then I try to check S2, it's the exact same memory. So, so we need a mechanism so that we are not pointing to the same memory, but in fact these are two different objects with their own memory, so that if we change one, it doesn't affect the other one, right? So this is where ICloneable comes into play. Okay, it has one method called clone, okay, that we will write code for, and once we write proper code for it, we'll be able to copy objects such that each object has its own memory. So that's the purpose of this, right? Next one, sometimes we create a list of, like an array list, or as I will introduce to you soon, generic lists or strongly typed lists. So if we have an array or a list of data, if we wanted to sort them, okay? So suppose you created an array list, let's pretend, and you put in it a student S1, student S2, student S, and so on, many students you stored in it, right? Remember, by calling the add method, you can put as many things in the array list as an example. So suppose the array list is called S list. Okay, so now the array list already gives us a sort method. So it already has a quick sort implementation. So if we call the sort, it will rearrange all the students that we have, but in which order? Okay, will it order them by first name? Will it order them by last name, or ID, or test 1 and test 2? See, we never indicated anything over here. So if you simply write this code, you will get an error message. And it will say, I don't know how to sort, because you never specified a field. Okay, so one of the purposes of IComparable is to provide comparison on a field, on a particular field, so that, for example, we can do the sorting, or so that we can do, for example, if S1 is less than S2. Okay, you'll be able to do those kinds of things if you overload the less than operator and then further provide a proper comparison over here. Okay, so anyway, so that's the purpose of the IComparable. Very briefly, IComparer is like a more flexible form of comparison. Okay, so more flexible comparison so that between two objects. Okay, so that if we are trying to sort dynamically, we can change the field. So sometimes we can pick first name to sort on, sometimes ID, sometimes last name. So this is a little more advanced, but anyway, let me show you the one by one, the typical code for this. And then in your next assignment, you will use these capabilities. So let's start with the cloning first. Okay, so typically what we do is we say class student, and once again assume we have those 5 fields over here. And if we want cloning capabilities over here, we will say :ICloneable. Right? Okay, and once you right click on it and say, what was that, quick actions or whatever, one of the quick actions will be implement interface. So once you choose implement interface, towards the end of your code, it will end up writing a simple function like this: public object clone, and begin curly and curly. Okay? So now our job is to provide the real code over here. So the typical code, if you have, let's say, a class like student, the typical code will look something like this. You will create a new student, so you will say st equal to new student. So this will give us complete new memory for the new student, right? Okay, then we will say st dot, since we are already inside the student class, we can access the private field directly. First name equal to this dot first name. Okay, so now once we use this keyword, what do we mean by it? Which first name are we talking about? The first name that was declared over here, right? So the class level first name. Okay, so now to understand how this code is being written, let's take a look at typically how this code will be triggered. So this code will be triggered something like this. Somebody will say student S1 equal to new student. And regardless, in the constructor or sometimes later, they will provide whatever initialization they need to do, right? Then they will say student S2 equal to S1.clone. Okay, so now if you take a look at the clone, what does it return? Object. So the right hand side is of type object. What's the left hand side? So remember, C#, like Java, is strongly typed language. Both types have to match. So we will typecast it ourselves to a student. So the type of the right side is student, type of the left side is student, right? Okay, so as you can see, suppose here once again, let's say we type Bill and so on. So once we say s1.clone, right, so we are triggering this. And once we use this keyword, so which first name are we talking about? For, whichever object triggered this, right? In this example, S1. So this is the first name for S1. So think of this code doing something like this. Okay, before we call this, let's take a look at student S1. Here's S1. In the heap, we have memory for first name and last name and so on, correct? And this is our S1 so far, right? Now let's go to the second line. Student S2. Okay, now let's call S1.clone. What did we do in S1 in the clone? We created a new student. So we created, let me go over here. We created ST. And let's pretend this is the first name. Because we said new student, right? So we'll allocate memory, complete new memory for first name and so on. Okay, so now ST is pointing over here. Okay, so now once we say st.firstName equal to this.firstName, okay, we triggered this through S1. So this is really the S1's first name. So, so remember over here, let's say we had stored Bill, Baker, and 1, 2, 3, 4, 85, 91. Let's pretend, right? So once we do st.firstName equal to the S1 or this dot first name, so Bill will go over here, correct? Very similarly, if I do st.lastName equal to this dot last name, so you can see, for example, Baker will go over there, right? And so on. So if I did it for all the 5 fields, and then I simply did return st. So what will happen as soon as the clone is called? We will end up populating all of the 5 fields into a new memory, correct? And we've already copied all the data from the existing to the new memory. So once we are done, we say st equal to s1.clone. Remember, this was the object being returned by the clone. So now what will happen? S2 will point to whatever our clone object, whatever st, whatever clone object was created. So now st is no longer needed because it was declared inside this scope. So st will disappear once the clone is done. Okay, but once we come over here, S1 is pointing to its own memory, S2 is pointing to its own memory, correct? Okay, so that's how we typically implement ICloneable. Okay, now there are a few complications in implementing ICloneable. So let me talk about those complications. Okay, so first of all, keep in mind that anytime we assign one reference type to another, okay, it is not creating another object in memory. Right? As we discussed, it is pointing to the same memory, correct? And let me again clarify it through example, right? For example, objects of a class, we refer to those as reference types. Remember, reference type is any type that's created on the heap, right? So if I said student S1 equal to new student, and whatever, okay, and then if I did student S2 equal to S1, correct? Is S2 pointing to a new memory or pointing to the same memory as S1? Same memory, and that's what I meant. If we assign one reference type to another, it's not creating another object in memory, it's pointing to the same memory, right? So S2, S1 are both exact same memory. If you change S2, it will end up changing S1. If you change S1, it will end up changing S2, right? Okay, what are the other reference types? Okay, if we take a look at reference types, okay, remember we have, as far as types are concerned, we have value types and we have reference types, right? What are value types? Value types are those data types which are created on the stack. So for example, in double and so on, right? All the basic data types other than string are created on the stack. So they are called value types. What are reference types? Class objects. What else? Arrays. Remember we discussed arrays are in Java and C#, they are created on the heap. So they are also reference types. Okay. So now let's pretend we go to the student class, and remember the two fields we had over here were test1 and test2, right? And the corresponding public get set properties. Okay. What if somebody says, you know, maybe sometimes we'll need 3 tests? Okay. So let's create an array of tests rather than simply writing test1, test2 as 2 separate fields. So if we were to create an array of tests, what will it look like? Remember in C#, if you, after the data type, if you put empty square brackets, that means you're creating an array, right? So let's say we call it test or tests, okay, equal to new int of 2. So what will that do? It will create array of 2 tests, right? Okay. So now let's pretend when you were writing the clone method, you wrote the code like this. Okay, after copying the last name and everything and the ID, you did st dot tests equal to this dot tests. And you said return st. So this was your code in the clone method. Okay. So now let's go try one example out. Okay, so suppose we did something like this. And again, let me pretend we initialized it to Bill Baker 1, 2, 3, 4, 85, 91. So this was our initialization via the constructor, right? Okay, then we do student S2 equal to S1 dot clone. Okay, and then we put typecast it to a student, correct? So now will S1 and S2 have 2 separate memories or just one memory?
2 separate.
2 separate memories, because in the clone we create a new student object, right? Okay, so now what if we do this? After we copy S1 into S2, right? We say S1 dot tests of 0 equal to, let's say, 50. Okay, in the beginning it was 85, okay? And now we try to do method box.show s2.toString. So pretend we have already written the toString method, so we are printing whatever data is in s2. So can you tell me what data will it print for s2?
85.
Original data.
Okay.
Original data.
Okay, so some of you are saying original, meaning 85. Anybody saying it might print for test of 0, 50? Nobody? Okay.
Yeah.
Okay, so a few of you are thinking it may print 50, right? Okay, so let's take a look at this code over here. So first, focus on what did I say over here. Anytime we assign reference time to another, does it create new memory? No, it simply points to the same memory, right? Okay, so now let's go, let me draw a cleaner picture over here and show you exactly what will happen in this case. Okay, let's take a look at the first statement. So student S1, okay, and here is first name, last name, ID. Okay, now there's no test1, test2, right? So there's a field called tests, right? Okay, so basically there will be a field called tests, which will further point to tests of 0, tests of 1, right? Okay, so now all of this memory is being pointed by S1, correct? Okay, so now let's come over here and so somebody creates S2 equal to S1.clone, right? So we call the clone method. So what will the clone method do? It will also create new memory, correct? ST equal to new student. So we'll create first name, last name, ID, okay? We'll create tests, and this test will be pointing to tests of 0 and tests of 1, correct? Okay, so now this is our ST object, ST equal to new. So if I put ST over here, ST is pointing over here, right? So now let's go further. ST dot first name equal to this dot first name. So remember, wherever this is, it corresponds to S1, because through S1 we call the clone, right? Okay, so what will it do? ST dot first name, so we'll put Bill over there. It will put Baker over there. It will put 1, 2, 3 over here. If that was the case over here. Bill, Baker, 1, 2, 3, 4. Here we had 85 and 91, correct?
Yes.
Okay, so now let's come to this line. This is the most important line. What will it do now? Okay, what is tests? Is it a individual value type, or is it a reference type? It's a reference type, right? So S1.tests, so basically ST.tests is over here. So we are saying ST.test equal to this.test, right? So all it will do is make this point to this memory. Okay, remember we don't, if it's a reference type, they both point to the same memory. So at this point in time, the tests in ST is also pointing to the same memory as tests in S1. So both of them are pointing over here. So in other words, this is disconnected. So sooner or later, this will go away. It will be garbage collected. So this will go away, right? So now let's go over here. S1.tests of 0 equal to 50. So S1 tests of 0. So what did we change it to?
50.
50. Okay. Now we try to print out message box.show s2.toString. So we go to s2. Sorry, I forgot to put s2 over here. So let's put s2 over here. And this is pointing over here. Okay. Because whatever was returned by this, s2 will be pointing over here. Student s2 equal to this one, right? Okay. So anyway, if we try to print it, it will print Bill, Baker, 1, 2, 3, 4. And once we try to print tests of 0, tests of 1, where will it go? So we'll print 50. Okay. Is that what we wanted?
No.
No, we wanted it, if you change S1, it should not affect S2 or vice versa, right? The problem is because we were trying to assign one reference type to another. So if a class contains reference types, you cannot simply assign them, otherwise it will be what's called shallow copying. So this is what we refer to as a shallow copy. Okay. See, what we wanted is we wanted it to leave it, be left, and not make it point over here, but copy the data one by one into our own memory, right? So there's two solutions over here. One solution is, as we are writing this line, we do something like this: for int I equal to 0, I less than this dot test dot length. Every array has a length property, remember? And then we do st dot tests of I equal to this dot tests of I. And then we return st. So if you take a look at tests of I, what is that? Each individual item in the array. Is that a reference type or is that a value type?
Value type.
Because it's an array of integers, right? So tests of 0, tests of 1 is integer. If you assign one integer to another, then it does not point to the same memory, right? So now this will work. So now, like I said, it will not make this point over here. So now it will basically copy one by one. So 85, 91, because remember, after we did the cloning, then we changed it to 50. Okay, so now if you run it, it will come out correct. Okay, so the moral of the story is that when cloning, okay, or in other words, implementing ICloneable, make sure you deep copy reference types in it. Okay. So for example, if there's an array involved, you go one by one and copy the data in the array. Okay, so now let me go to the computer, create this scenario, and show you a couple of interesting things.
I have a question.
Uh-huh.
What makes this better, or why makes this different from simply just implementing your own clone method?
Meaning not writing ICloneable interface? Very good question. Okay. See, and the answer lies in, like I was saying, if you create a class, and before you create a class, if you define an interface, right, it sort of standardizes how your class will be used. Okay. So for example, let's say we don't write the interface. Okay, you create a student class, and rather than calling it a clone method, you may decide, oh, let me call it a copy method. Okay, somebody else in your group creates a class and says, oh, copy is not a good name for a method. Let me call it duplicate. Okay? Somebody else says, oh, let me use clone, right? So what happens as you're calling different classes to make a copy of that object? Sometimes you're saying, you're calling the copy method, sometimes duplicate, sometimes clone. So it becomes a sort of a mess, okay? But on the other hand, if we standardize that, if you're programming in this language, anytime you have to copy, it will be done through an interface called ICloneable. So everybody knows, oh, if I'm trying to make a copy of that class, I will call the clone method. So does that clarify?
So basically, from a code standpoint, there is no difference.
Code point of
From a
view, there's
human
no.
understanding.
It standardizes how should we use a particular class. It clarifies it so that there's no ambiguity. Tomorrow I created a library, gave it to you. You don't have to ask me, oh, how do I copy the objects? What's the name of the method? If it is in C#, it standardizes as ICloneable. And again, that's one of the key ideas behind interfaces, so that we make the software as easily self-discoverable as possible. All right, so let's move on. Okay, so I'll create a small Windows application and show you these concepts. So while it's loading, let me launch the Visual Studio. I'll create a new project. And okay, I'll pick a Visual C# Windows Forms application. CS 440 fall 2003. No signal. All right. Let's see if we go to PC. Tricky last time, how to turn it on, try turning it on again. So let me try in a couple of minutes and let me keep explaining in the meantime. I'll try kind of coming back to it. So anyway, one of the things that I was mentioning is if you have a reference type inside your class, right? And you wanted to implement ICloneable. One option is we write a loop and copy one at a time. For example, if it's an array, copy the data one at a time, right? Now, fortunately, all classes that have been created, pretty much all classes that are part of the .NET library already implement ICloneable. So you don't have to go one by one and copy things yourself if it is a reference type. Okay, so all classes in .NET library implement ICloneable to begin with. Okay, so alternatively, rather than writing a loop yourself, okay, an easy way to do this will be you will say st.tests equal to this dot tests dot clone. Okay, so the arrays themselves in the .NET library give us ICloneable, so we can call the clone method, right? But what does the clone method return? Object. What is the left-hand side? An array of integers, right? So now you will have to typecast it to in empty square brackets indicating it's an array. So this one line of code will be a lot better than writing two separate lines, right? Okay. Try it one more time. Okay, so now let's pretend in our student class, okay? Suppose every student has an address, like street address, city, zip code, and so on, right? So one option is we add a field called string street address, then string, for example, city, string, zip code, and so on, right? So we put 3 fields over here. And the other option would be, right, then we look over here. No signal. Okay, let me try one thing. No, that's okay. Leave it there for 1 second. Let me try one thing. Oh, really? Hang on 1 second. Last time I tried this. Yeah, I think we got it. Okay, so let me create a new project and let me call this Interfaces. Okay, so the name of the project is Interfaces, Windows Forms Library, Windows Forms Application in C#, right? Form is the 2015 is the location, so once I click OK. Okay, so first let me bring the existing student class over here. So if I right click on name of the project, add existing item, and I will go to one of our previous projects. So for example, if I go to, let's say first, okay, I'll pick the student class from our first project. Okay, since it's in a different namespace, let me change the namespace over here to Interfaces. Okay, and quickly refresh your memory. We have first name, last name, ID, test1, test2, compute grade, right? That's a simple class over here, right? Okay, how do we implement ICloneable? As we just discussed, all you have to do is put colon and then say ICloneable, right? So we recognize the ICloneable. Okay, then right click on ICloneable and implement interface, or in your case it might first say quick actions and then implement interface. So anyway, pick implement interface, and like I said, what it will do is at the end of the class it will write the clone method for you, right? So now we can go write student st equal to new student, so we can create brand new memory and one by one copy the fields. St dot first name equal to this dot first name, and so on, right? What if we have arrays, right? So let me leave test1, test2 as is, but let's also add an array. Int test equal to new int of 2. Okay, and then if I right click on tests and refactor encapsulate field, okay, so we'll end up generating the public property tests, right? So if we wanted to now do copy proper cloning of this array as well, which is part of the student class, as we discussed, what will we do? We will say this dot tests equal to
this or st?
sorry, st dot tests equal to this dot tests. Okay, so do you see if there's a clone method? You'll see there is a clone method, right? And again, if you forget, and that's the good thing about Visual Studio, put your mouse on it and it will tell you what does it return, an object, right? So to satisfy the compiler, we will typecast it to the array of integers, right? So anyway, so one option, as we discussed, would be one by one, start copying the last name equal to this dot last name, and only the reference type you will call the clone on it, right? And then you will do return st. Okay, and again, I'll have, so if we have 5 fields, how many statements like this I will need to type? 5 statements, right? What if I have 20 fields in my class? 20 statements, right? So again, that could become a little cumbersome. So fortunately, we have our base class object gives us a very easy method called member-wise clone. Okay, so if I go st, rather than saying new student, if I say st equal to this dot member-wise clone, I will copy all the fields. Okay, so it uses reflection internally and copies all the fields. So if you have 5 fields, it will copy them. If you have 20 fields, it will copy them. Why is it complaining? If I put my mouse on it, what does member-wise clone return? Object. So obviously I have to typecast it to student, right? Everybody agrees? Okay, now if I put my mouse on member-wise clone, take a look at the description. What does it say? It creates a shallow copy. What it means is internally we'll just keep assigning one field to another, one field to another. So it will work for every field, except which field it will not work. It will not work on the array of tests, right? So that's okay. What we can do is, so now I don't need to type any of these because these are regular value types or strings. String behaves like a value type. So anyway, so now the only field that will not be properly taken care of by this, I can manually do it. So I can say st.test equal to this.st dot and return st. So now it doesn't matter I had 20 fields or 30 fields, this code is a lot quicker, right? Everybody agrees?
Even the test clone, it shows shallow copy.
Test clone, shallow copy of the system array. Right, but remember what's contained inside the array? just integers. So shallow copy for integers works. But if it was an array of students, then it will not work. Okay.
So member-wise clone will also copy the test.
It will copy the test, but it will do like this dot st dot tests equal to this dot tests. It will not go inside the array and copy one element at a time.
So,
But if we call the clone,
like even after we call this the second line, even then it will copy tests.
no, see, first line did st dot tests equal to this dot test, but that's a wrong type of
Yeah.
copy.
Yeah.
The second line, when we call the clone, will do a proper copy.
Even then, like after implementing st.test is equal to int this test.clone. Even then, the internally shallow copy will be made.
Okay, so to explain again, the first part does a shallow copy of all the fields, meaning assigns one field to another, one field to another, but if it's an array, it will not write a loop for it, right? We have a problem if we do not write the second line. The array will not be properly copied. To copy the array properly, we call the clone on the array itself, which will do a shallow copy on the elements of the array. But the elements of the array are integers, so it's okay. If the elements of the array were reference types, then it will not be okay. Okay? So let me demonstrate it to you. Okay, so if I go to the toolbox, double click on a button. Okay, so let's go, let me call it test and BTN test. Okay. So first, let me do this. All right, let me first do student st or s1 equal to new student. Okay, and by the way, since I don't have the constructor over there, right? My one option will be to go s1 dot first name equal to, let's say, Bill. So one by one, I start assigning whatever the fields are, right? Alternatively, C# does give us what is called automatic construction. So let me start introducing some of the more powerful features of the language. So even if you have not written a constructor, if you type the left curly brace after the name of the class, then hit the space on the keyboard, it will give you all the fields that you have not initialized yet. So now you can go and simply say first name equal to Bill. Okay, comma. And then again, if you hit the space bar, it will take that field out, so it will tell you what's the remaining fields you haven't initialized yet. So you can go and, without writing a constructor, use this feature. Okay. So suppose ID equal to 1, 2, 3, 4. And because I want to handle the tests separately, let me do this, s1 dot tests of 0 equal to 85, s1 dot tests of 1 equal to 91. Okay, and now student s2 equal to s1 dot 1. Okay, and now let me try to change s1 dot tests of 0 equal to 50, and try to print out message box dot show s2 dot tests of 0 dot toString. Okay, and before I test it, let me go to the student class. and remove this, comment this out. Okay, so now it's totally shallow copy, right? So as you saw, member-wise clone produces a shallow copy. So what will be the result printed over here? 50, right? Because it's pointing to the same memory, even though I'm changing S1, S2 will also get changed because the array is pointing to the same memory, as I explained, right? So let me run it. So if I click, you guys see whatever we expected, it came out, right? So now if I go and take care of the shallow copy by explicitly cloning the array. So now we are cloning the array of ourselves. Okay, and now if we run it, so do you see it works correctly? It's changing S1 does not change S2, right? Okay, so very similarly, suppose I create a class, add another class in the project, so add new item. Okay, pick a class, and suppose the class is called address. Okay, so now suppose this has string city, string street address. Okay, and then string city, right? And zip code and so on, but let me just leave two fields over here. So if I right click, refactor, encapsulate field, take out the extra blank line, right click, refactor, encapsulate field, take out the extra blank line. Okay, so anyway, so now I have a address class encapsulating the address. What if every student also needed an address? So if I go to the student class, okay, and maybe just, so I'm inside the student class, let me say address addr equal to new address. And because it's a class, to allocate memory, I have to use the new keyword. Otherwise, I will not be able to store anything in the student class, right? So if I right-click, refactor, encapsulate field, so ADDR is one of the fields now inside the student class, right? So if I do a member-wise clone, what will happen to ADDR? Will it be copied properly, or will it be... Remember, it's a reference type. So for reference types, shallow copy, all it does is assigns one variable to the other, which doesn't mean it's copying the actual memory, right? So to demonstrate that this will not work, let me go to the form, view code. Okay, for S1, let me set the S1.addr dot, let's say, city equal to Bridgeport. Okay, now what I will try to do is print out message box.show s2.addr.city. Okay, and after we do the cloning, see, here's where I'm doing the cloning. Okay, so if I run it right now, what will show up for S2 city? Bridgeport, right? And to verify, let me quickly run it. Okay, that was the previous message box. You can see it shows up as Bridgeport, right? Which seems like it's correct, but after we do the cloning, let's change the S1 city. S1.addr.city equal to, let's say, New York. Okay, so now changing S1, if it's proper copying, should it change S2?
Yes.
It should not, right? But if it is shallow copying, then S2 will also become New York, right? So if I run it, Okay, so the S2 got changed to New York also, right? Which you guys expected anyway, because what is ADDR? Is it a value type or is it a reference? It's a reference type, right? So how do we fix this problem? What should we do so that it does proper cloning? Okay, remember tests was a reference type, so we have to call the clone on it. Okay, let's call the clone on the ADDR also. So what if we do this? st dot add, since we are inside the class, we can do addr equal to address. We'll typecast to address this dot addr dot.
No.
Is there a clone over there?
No.
No. Okay. Why there is no clone?
Because we created that class.
Because we created that class. See, if this class was created by the .NET library, they would have already implemented ICloneable. Since we created it, there is no clone. So what's the solution?
We implement the cloneable in address.
We implement ICloneable in address, exactly. So let's go to address and implement ICloneable. So if I right click on ICloneable, refactor encapsulate field, oh sorry, I need to do implement interface. Implement interface, right? So now, what code shall I write? Let me ask you a question. If I, see the quickest way is return this dot member-wise clone. Will this work?
No.
Why not?
It creates a shallow.
Right, but in this class, what kind of fields do I have? Or do we have?
Street address and
Street address,
Yeah,
which is a
valid.
string, but remember string, even though string is a reference type, it behaves like a value type. So once you assign one string to another, it actually creates new memory and copies the data from the original string.
But even the array had integers.
In this class, there is no array.
No, like then too we had to individually.
No, because the array itself is a reference type. Okay, so that's why you had to call the clone on it. Okay. Anyway, so over here, so the question is this correct or will this give us a problem? It's correct, because the only thing we have is a street address, which is string, city, which is a string. So as long as all the fields over here are integers or doubles or strings, it will work. But what if I had one of the fields over here as an array?
Then we have.
Then you have to call further the clone on the array, right? Okay, so try to understand this concept, because on the exam I'll try to trick you, not on purpose, but make sure you understand the concept. So I'll give you a scenario where you'll have to use member-wise clone wisely. So once you go home, try to practice, play around with it, make sure you understand it. Anyway, the answer is this is correct, because all the fields in the address class are such that the shallow copying works on them. Okay. So now if I go to my form, to the student class. Okay. So now if I try the clone, will it come back? You can see it does, because we implemented ICloneable. Right? Now to test it, remember, let me show you the test code again. So we started out with S1 with a city of Bridgeport. We made a clone into S2. Okay? Then we changed S1 to New York. If it is proper cloning, what is the expected answer? Bridgeport. Changing S1 should not change S2, correct? So if I run it, click on test. So this is Bridgeport. You can see it's working correctly, right? So let me stop here. Next time I'll give you a quick overview of IComparable, IComparer, and then we'll go from there. Okay? And I forgot, I'll put an assignment on the website today. So try to do the assignment because that assignment will also be important for the test.